Let's talk about this concept of equipotential. 2 points are equipotential if they have the same potential. For an equipotential line, every point on that line has the same potential. And for an equipotential surface, every point on that surface has the same potential. It's a lot like a topographic map. As you can see here, I have an example of a topographic map. And this line here represents every point on this line is at an altitude of 200 meters. This line represents an altitude of 200 meters. This is like an equipotential line. Every point on this line has the same potential. Now, in this case, with regards to a map, it's actually gravitational potential, which we don't ever talk about. But it's the same idea applies to this idea of electrostatic equipotential, which is what we're looking at right here. An important thing to remember about equipotential lines is they are perpendicular to E-field lines. So let's take a look at a situation. Let's look. This is actually a capacitor. We have two parallel plates that are oppositely charged. And the electric field goes from the positive plate to the negative plate. So if I wanted to draw my equipotential lines, it's actually not that difficult to do because they're perpendicular to the E-field lines. So I have to draw a line that's perpendicular to every single one of these E-field lines. And that's that right there. And I can draw another one down here. And we'll draw one more. And these lines these are equipotential lines, and they're at different voltages. So for example, let's see, this one might be, I'm just making up numbers here. This might be 10 volts. This might be 5 volts. This might be 2 volts. Again, I'm just making up numbers. But every point on this line up here, this first one, doesn't matter which point I pick, its potential would be 2 volts. On this line, any point I pick on here, its potential would be 5 volts. Now, a key thing to remember with regards to equipotential lines, equipotential surfaces, it has to do with work, the work that the electrostatic force does. So if I put, let's say I've got a charge. Let me just go ahead and quickly draw one here. So there's my charge. And let's say I move the charge along this 2-volt equipotential line. Doesn't matter which way I go, but just to keep it straightforward, we'll say I'm moving it to the right. So as I'm moving it to the right, I'm interested in knowing how much work the electrostatic force is doing on it. So the formula for work, we know what that is. Work equals FD cosine of theta. So specifically, I'm looking at the electrostatic work, the work done by the electrostatic force. So let me put little subscripts here. This is the work done by the electrostatic force. D is the distance that the object actually moves. And theta is the angle between the force and D. I'm sorry, I should say between the force and the motion. It's the angle between the force and the motion. Okay, so if I move, let's say I move this charge to the right. That's its velocity, it's to the right. Now remember that these E-field lines are perpendicular to the equipotential lines. And that's important to know because remember that the electrostatic force is equal to the charge times the electric field. Now, because the charge can be positive or negative, that means the force can be either parallel or anti-parallel to the electric field. But even if the force is anti-parallel to the electric field, it's still going to be perpendicular to the equipotential line. So that means as this charge moves along the equipotential line, it's always at a 90-degree angle to the force. The motion, I should say, the velocity is always at a 90-degree angle to the force. So that means, going back to our formula for work, we got the cosine of 90. And the cosine of 90 is 0. And anything times 0 is 0. So that tells me that for any particle, any charged particle that moves along an equipotential line or surface, no work is going to be done on it by the electrostatic force. Sometimes we might say no work is done on it by the E field. Those are interchangeable sentences or statements there. Either way is considered appropriate.